Hey, YouTube, how is it going? I hope all is well. So today we're gonna we're gonna touch back on a few things. First and foremost, there was a gentleman in the comment section of the last video, and I thought it was kind of funny. Maybe he was taking a jab at me. I don't know, but because I'm a plebe or whatnot. But whatever. In either case, he said, "Building it better than Fender did?" Question mark. And then he goes, "What? Like a high watt?" And I thought it was funny because while that is true, there's no debating that a high watt in any variant was built better than pretty much anything Fender ever did, in terms of the looks especially, but build quality altogether. There are some caveats to the way that he builds his amps, or built his amps anyway. So while they look amazing and there's no debate about how beautiful they are laid out and all that jazz, there are some downsides to the way he built his amps. Not to say that mine's any better. I'm just saying that just because it looks good doesn't mean it is. I want to kind of refer it to like the hot to crazy scale. The chick might be super duper banging, but she might also be super duper crazy as well. So you're looking for that magic spot. And while his stuff definitely looks like a supermodel, she's a little on the crazy side, okay? So keep that in mind. That we'll leave it at that. Anyway, so we went from this to this guy here. So this is kind of more or less completed. There's a couple faults that I still have in here, but I did manage to clean this up down here a little bit. Got rid of that extra dot that was over there. Didn't need to be there. And then, got all the values kind of squared away. I needed to move this down here, though. I don't know what the heck happened there, but obviously this is just a little more touched up and just cleaned up. You can see here I changed this layout a little bit here so that it, just made a little more sense. It was just a little bit cleaner, but this went from that to this. So this is the layout of that schematic that you were just looking at. Now, I will do pretty much anything in my power to make sure that all the high voltage HT stuff stays on its side of the turret board. This area here is not such a big deal. This is at the noisy end, so ground running off that way is not a big deal. I could just run it off this way too if I wanted to. So in either case, something's got to come from here over to an actual ground spot on the amplifier. So how it does that is irrelevant. I could probably actually take it from here and go somewhere over here if I wanted to as well, which we may, I don't know. We'll see about that. In either case, that's not the point. This was as clean as I could get it in as small of an area as I could get it. So there's a lot going on in this thing. But I felt a pretty good job of making it so that all the sensitive stuff is on this side, here, and all the noisy stuff's over here to the left. So, again, DIY Layout Creator is what software I use for the layout stuff. It's more of a way for me to just create the layout for the turret boards that I use. You can tell it what kind of spacing you got and all that jazz, and this kind of helps a lot. You can also tell it to you can give it the actual dimensions of the parts that you're putting in to know if they're going to fit or not. All these capacitors are the actual size, that they'll be relative. Obviously, this is zoomed in a bit, so that it's bigger than it would actually be. But I know everything's going to fit because of the fact that, it's laid out the way it is, and the sizes of the parts are relatively the correct size. So that's good. We're going to see if this is going to work out here. This is the bias resistor for the output tube. It's not wise to put the stack the two this way. So this is the bypass cap for the output tube here, and then of course the bias resistor on top of it. That's not wise to do it that way. I may have enough room here or even here to move these over on one more notch and make it so that I can give this its own aisle, if you will, to help convect heat a little bit better. The only fortunate thing I have going on for me here is that I can raise this up off the top. I mean, obviously we're looking down at it vertically, but, I can raise this up enough so that it doesn't burn up the bypass cap, and it is going to lay in the orientation that you see it. So it's not going to be upside down. So all the heat coming off of this resistor is literally floating up into that bypass cap. So I got that going for me as well. So it'll be in a way where the heat convects upward off of everything, meaning that this bypass cap should be safe. We're going to see. There's not a whole lot of wattage here. I think in the other amp I built, I have it biased pretty close to 100%, and it's warm to the touch. Like, it doesn't even get hot, so it's not that big a deal. So this one, I don't know how different that'll be, but if you've ever wondered how to do a full wave bridge rectifier diode string in a straight line, this is how you would do it. You get 2 diodes going one way, 2 diodes going the other way. You got your ground reference going off out of this point here, and then you just connect the outer 2 together. I over exaggerated this one a little bit here. Obviously, you don't have to go quite like that, but whatever. That allowed me to get the HT to come out down here on the bottom and still get the HT to come in kind of at this angle here, so it should clear everything. These will obviously be twisted together, so there is that. This should be about how it lays out inside of the amp itself. I don't have it broken apart enough to know the exact measurements, but I know relatively that this should be pretty close. I know that there's a standoff in the amp here, and there's another one here somewhere, probably right in the middle of this mess right there where I don't need it to be, but I'm hoping it's going to land like right here. We'll find out. So, enough said. We are now going to go into the fun part where you get to see a montage sped up video with me just ripping apart the old amp and then rebuilding the new one with the turret board and getting all these parts, putting it together, and then we'll put it in the amp and we'll be done, and you'll just kind of get to see all that done sped up. So enough of me yip yapping. Let's get down to it. We'll talk to you in a few. Bye. Hey, how is it going? All right, we are ready to do the initial startup and test of this amplifier. Truth be told, I've already gone ahead and done all of this, so I already know everything's going to work, but, whatever. I'm going to kind of walk you through it here because this one's a little bit different than some of the other ones I've done. I apologize. I am not going to set up my recording mic for recording the audio on this. It's just going to be through the cell phone or through my iPhone or whatever. So it might sound a little bit different, but we're just going to get through this. So first and foremost, very first thing you should always do before you go and just turn on the amplifier is go through your schematic and double check all your connections and make sure that you did everything right. I'll tell you why. So I'm used to wiring, these two, high-low inputs, high-low, or in your case, it'd be high-low, right? So high is on the top, low is on the bottom. Well, in this case, they're laid down, horizontally with each other, and high is on the outside and then low is on the inside. So I wired this in backwards. So I had to redo the wiring here. Oops. So be sure that that you're building with your schematic in plain sight. I was going off of memory, and muscle memory got the best of me. So do be mindful. Always check your schematic and double check all your connections. Then you can go through the startup process that we're about to go through. So what is that process? First and foremost, you plug the thing in with the switch in the off position. We just want to get a couple of voltages first. We just want to know for sure that everything's working the way it should. So we're going to take our multimeter, we're going to connect a ground point. We're only really worried about AC voltages at the moment. Always have your drink of choice. My day is done at work, so I'm still in my work clothes even. But in either case, that's much needed there. So we got that. Now we're going to turn the amp on. And with any luck, you don't get any sparky, boom, boom. That would be ungood. In this case, we have no sparky, boom, boom, because that is good. So what we're really interested in making sure is that we have an HT voltage and that we have heater voltage. Those are the only AC voltages inside of the amp that we're really concerned with. So we're going to touch these guys here for our AC voltage, Make sure you're in the highest voltage range, of course. And you should see something. I don't know what it's going to be with any given transformer, but in this case, we have 287 on one side, and I believe it was a couple volts off on the other. 291, so like 4 or 5 volts. That's okay. There's always a little bit of variation inside of a transformer. It would be ideal if they were the same voltage on both sides, but they just aren't always. So whatever. We're not going to have any AC voltages beyond that because it's going through the diode string there, which means every other voltage beyond that point is going to be DC. So in this case, we're just going to go to the heaters, which we see 3 volts on that side and 3 volts on this side. And if you're brave, you can put it on both. They always say don't put 2 fingers in there, but you can see we got 6 volts. If we go down to a lower range, we'll probably see that we're closer to 6.3. Let's see, 6.2. That is dead nuts. That is great. They actually did a really good job on the power transformer for this amplifier. They didn't kill this amp with a ton of voltage, and they got it so it was just like right on the money. So that's one thing I'm happy about with this particular amp, aside from many of its other shortcomings, is that the power transformer was done up right on this particular build. All right, so now we are concerned about DC voltages. We just want to know that we have DC voltage down the line where it's supposed to be. So now we go into DC range. Again, the highest voltage range that you have, 600 volts. And we want to check here at our first node. So we should see a number. It will read high because there is no load on the amplifier right now. 401, not bad. It's not going to drop much on the other side of these voltage droppers here, if at all. We lost a volt there, and we may lose another volt here. A few volts. This is a 10K resistor, so there's more resistance there. So it will drop a little bit more than this 2K resistor will. So we're good there. We got voltage at the actual plates. We're good there. And of course here. And it's reading all over the place because I'm not making good connection. There we go, 361. All right, so we know that we've got voltage where we are supposed to see voltage. If you really wanted to check a little bit more, you could also check at the tube socket here to make sure that you got heater voltage there. I know that we do. It's 3 volts. If we go across both sides, we would have 6 volts. So the heaters are working good. Our HT is working good. Everything is working so far as it should. So now we are ready to move on to the next step. Turn off the amplifier. It's probably best if you unplug it, especially when you're working with an open amp such as this one. But in this case, I'm going to play it brave and get through this video. We're going to put on our preamp tube. This is the one that came with the amp. And we'll just wiggle it in there all nice like. All right, it's in there like it should be. Sorry, I got my little box here to help prop this up. We're going to need this later when we put in the power tube because it will, the power tube, I don't want it resting on my mat. That would be ungood. All right. So now what we're looking to see is A, glowing lights inside of the tube, and B, we're looking to see that voltage has dropped along our DC voltage, HT rail. Now, the reason we only care about that, or voltage drop, is that we know then that the preamp tube is at least conducting. If you don't see a voltage drop, that means that the tube isn't conducting, which means it's probably not working. So we should see a slight voltage drop, not much. So we were at 400 and something before, and we've lost about 6 volts. So not bad. And it'll continue to go down a little bit further as we go down the line. So we were at 360 on the other side of this before. So we had about 360 there before. Now we're down to 227. This tube is on. It is conducting. That is good news. Now, what that means is that we can, after, of course, visually inspecting to see that the heaters are glowing, which we know that they are, we can now put in our power tube. So, same deal. Turn off the power. Make sure you can safely put in your power tube. And we're going to go ahead and do that now. So, that should go right around like that. Okay, nicely seated. Grab this guy here. And ta-da! All right. So now what we're going to do when we turn this thing on, we got to make sure that we have a speaker load attached. That's what this guy right here is for. It's been plugged in the whole time. But make sure that you do have your speaker load attached to the amp at this point. What we're looking again for is a more significant voltage drop along our HT rail. So turn on the amplifier, let things warm up a little bit. And what we should see, or what at least I know that we'll see in this particular amp, is about 350 volts at the plate of the tube. So that's really good for a 6v6. 350, I think, is kind of the sweet spot for a 6v6 myself. So at the actual plate, if you measure it through the power or the output transformer. You see we're at 348. So this transformer is spot on. I'm happy with where this is at. And as we go down the line, we should have, I've said it before, I think that you should have a 10 volt difference at the very minimum between the screen grid and the plate voltage. We're at 344 now. So it's not as low as I'd like, but if you actually measure it at the screen grid, you'll see we're about 8 to 10 volts lower than the plate. As long as the screen grid is lower than the plate, you are okay. I kind of like it to be at least 10 volts, preferably 15 to 20 volts lower. In this case, I'm not going to argue. There's a lot of variables that come into play. You can't go super large with the screen grid resistor, and of course, depending on what you need beyond this resistor, this dropping resistor here, you kind of got to be mindful of, you know, the size that you put in there for that. So again, just generalization, as long as the screen grid is lower than the plate voltage, you're okay. But I like to see at minimum 10 and, you know, a little bit more if possible, but this is okay. So we can see there that we've gotten a voltage drop, of course, 343. It'll drop even more down on this end. 318, I love that number. I usually try to get my preamp valves, you know, my front end valves, not my phase inverter, but my initial preamp valves right around 300 to 320. Anywhere in that range, I think, is kind of the sweet spot. So on the other side of the plate, so actually on the plate of the tube, we're seeing right around 202 volts. Anything between 180 or 160 to 250 volts on the actual plate of the preamp tube is not too bad. That's a pretty good range. So we are spot on with this guy. Now we have a couple other things that we need to figure out. Now, because this is a Class A amp, it doesn't have a center tap for the output transformer. So we can't do the output transformer shunt method the same way that you would with other amps. So in order to get the dissipation for this amplifier, we're going to do it through the cathode bias resistor. Since most all Class A amps are cathode biased, it's just a really quick and easy way to get where you're at. So what you do know is that one tube is capable of X amount of milliamp current draw, or cathode current, right? And in our case, we know that we are shooting for about 43 milliamps. That's about all we can manage on this tube with the amount of voltage that we got. And we know that because if we go to Rob Robinette's tube bias calculator page, web page that he has, we can punch in a couple voltages and it will tell you what the safe current draw is, among other things. So let's figure out what that math is. Now, the plate to cathode voltage is actually the voltage that we need. There are two ways that you can come up with that voltage. Way number one, or method one, is to measure literally between the plate of the tube and the cathode of the tube, which is this guy right here, in DC volts. And you'll see that we have 323 volts. All right, so we'll write that number down, and then we'll enter it into our plate to cathode voltage inside of Rob Robinette's tube bias calculator. And so we'll hit the calculate button after telling, of course, that we have a JJ6V6S or whatever tube that you may have. The other way to get that same measurement is to measure the plate voltage. So in this case, we've got 345 volts. We'll say 345. And then you measure on the other side of this, or excuse me, you measure from the cathode to ground. So in this case, we just put ground over here and we measure here. And what you're going to see is we've got 21 volts. If we go here, it's just a little over 21 volts. So 21 volts is what we're going to say that the voltage drop across this cathode resistor is. So if you take 21 from the 345, what does that leave you with? It leaves you with that 323 or some odd volts or whatever that we had. So but that's how you would do it. So if you measure from ground to plate and then from cathode to ground, you get those two voltages. You subtract the smaller voltage from the larger one, and that will give you the cathode voltage, or the voltage across this resistor. Or you just measure across the resistor and it tells you the same thing. So one of them's a little bit quick and dirty. The other one's, you know, probably more methodical. All right, moving forward. So now what we need to do is enter some more data into the bias calculator that Rob Robinette has. So we're going to tell it that the number of tubes that share a cathode resistor is 1. Then we're going to tell it the voltage that we have across that cathode resistor, 21 or 21.2. And then you tell it the size of the resistor. So in this case here, we have a 470 ohm, and then you hit calculate. It's going to tell you a few pieces of data. In cathode bias mode, we know that we are shooting for at least 95% of plate dissipation, and you shouldn't go over 100%. We are over 100%. The safest, the max safe plate dissipation that we can have with this amount of voltage and with this particular tube is about 43.3 milliamps. We are running at 45.1 milliamps, that is. That's a little bit too much. So we're running at about 104.3% of plate dissipation, or PD as it's also known as. We're shooting for more like 95. So we don't need a smaller resistor here. We actually need a larger one. I think a 500 ohm would probably put me right at 100%. I think a 510 to 520 or whatever other value is in between 500 and 550 would probably be a good number for that cathode bias resistor there, which should put me a little over 95 million or percent of plate dissipation, shooting for about 42 or so, 41 to 42 milliamps of plate current. That would make this amp run a little bit happier. Now, what we do know is, well, what I do know anyway, is that this tube is okay running at a little over 100%. It's not red plating. It sounds okay. Although I prefer to err towards the side of safety for some things, so I'll over-engineer, or I will make sure that my tubes just really aren't on the ragged edge. So I prefer to run them a little bit in the safer margin. 95% I think is safe all day, especially when you're running the tube at the voltages in which it's intended to be run at. Some of the Fender amps are a little egregious, where they're putting, 480 volts on a plate that's, the design spec says 350 on it, whatever. But that is the quick and dirty way to do this. So now at this point, what we need to do is figure out if it's actually making any kind of noise. So I'm going to go ahead and turn it off. I'm going to make sure that everything else is ready for me over here. So turn on a couple things, plug in a guitar, and here's signal. So we're going to plug some signal in. Boop. Turn the amp back on. Turn the volume up. I have mine going through an attenuator, so it's going to, drop the volume a bit. And I can already hear noise. All right. Sounds like a champ to me. So there you have it. This amp works. I've already went ahead and did a couple of other things that you may not have seen in the build video, or the montage, if you want to call it that. So I did put in a feedback loop. I would initially started without it. Some people like it that way, some people don't. It has a little more gain without it. In this case, it has a little bit too much. I may actually drop this resistor here down. This is the dropping or grid link resistor for the power tube. I may bring that down a notch just to drop off some of the gain going to the power tube, because we are spanking it pretty hard. I don't know yet. We'll see. The owner has gotten a chance to hear it already. He likes it where it's at right now, but I don't know. I kind of feel like it's got a little bit too much. So we'll come to that battle later on. But there you have it. This amp works. It's a lot cleaner. We went from all this mess down here to, I think a much better amp altogether. This thing is dead quiet. No hum, no buzz. The original design did hum and buzz a little bit. So I'm happy. I hope you're happy. So let's do some listening tests. All right. We're going to stop right there. I was about to introduce the song to try to show off what the sound samples of this amp versus the original one were. I decided we're not going to do that this time. It would just add another, 5 to 10 minutes worth of time to this video. It's already getting a little long. So we'll just do a whole nother video where we can break down the samples a little bit more and try to, give you some context on the differences between the stock amp and this one here as it's been redone. So in either case, thank you so very much. Take care. We'll see you on the next one. Bye-bye.